Okay, to start off with, we're just going to get a simple cube, and we'll just adjust the size here to 2 and adjust the scaling to make it rectangular, so 0.75 on the y-axis and 2 on the z. We'll go into hidden line mode here so we can see a little bit better. Next thing is we want to get the legs, so with the radius at 0.25 and the height at 3. That should be about good. What we want to do is translate that on, rotate that on the z-axis, and we want to offset it slightly. So I'm going to make it 22.5 degree angle back. So what I'm just going to do is translate that out and translate that back, something like that. That's good. We can duplicate that and just set one for the front leg as well. It's about there, and duplicate that one more time. And we'll put that right in the center. And this one we want to have angled the other way, so I'll do minus 22.5 there. There we go. So we want to make all these three guys rigid bodies, active rigid bodies, since they'll be moving. And then we want to set up the constraints between them. So I'll use the multi-constraint tool and then create a hinge joint between each of them. There we go. And last thing we want to do is just position the hinges so they're centered a little better along the joint. So I'll just center it there. Roughly something like that. And then what we can do is just select everything, create initial state for it, so we're good to go for that side. And then we can just take these guys. What we want to do is turn the motors on for them. So select the 3 hinges, go to the motor tab here. Actually, I'm going to take the spring and dampening off for now, so it's kind of frictionless rotation. Make the motor active. We're going to give it a velocity of 300 and a torque of 1500. So the maximum torque is the maximum rotational force it can exert to try and accomplish something. And then the velocity, of course, is the constant velocity it's maintained at. So once we have that, what we can do is just mirror this setup on the other side. So I can just select all these guys and then do duplicate symmetry on the YZ axis. And then once I have that, I can just set the initial state for that side, so it knows that that's the basic position we want to start at. And what we want to do is go back to the 3 joints on this side, and we're going to make the velocity in the opposite direction, minus 300. So they're rotating in the right direction to give a forward propulsion. So with that, we're pretty good to go. Let's just play that back and take a look. And that's looking pretty close to what we want. Let's just add a gravity to keep the thing facing downwards. And we're going to create a simple grid for a floor. And we'll just scale that up and translate that down. So once we have that, we can just make that a passive rigid body object. And that's about it. Let's play that back. And there we go. We have our creature walking. I can make the timeline a little longer so we can see what's going on. So obviously this is kind of, you're not going to see this in the next Hollywood movie, but this is kind of the framework or architecture for building vehicles or kind of robot design. So obviously you can go in and adjust settings. We can offset the arms, move the front ones a little bit further back or a little bit forward, just to get different looks. And it's kind of a cool way to actually just tune the look of things. Just set the initial, let's go back here. Set the initial state. Try that out. So you can see it's a really neat way to kind of try out different systems and see what kind of motion you get, and then refine it from there to actually the final system you're going to use. You can also play with the gravity and the forces to see how to react to that with different movements. So it's pretty fun stuff. We're going to look at one more little robot scenario, a biped, which is slightly more advanced, just using a few more constraints. And then from there, we'll look at specific scenarios.